Hello and welcome to the channel. So we've got a 65 deluxe reverb here going on. We had a 68 on the channel a few weeks ago, and now we've got this one in tow, and we're going to have a look at this, see what it needs, see what faults we have on it. Now, I've been getting one or two comments from people from other countries who are struggling to understand me, and YouTube now has the auto dubbing language facility, and I think it's probably because of my accent, which I try to disguise on the channel and speak properly, but sometimes it slips. So I'm going to try a bit harder to speak more clearly. But anyway, enough of that waffling. Let's get on to this deluxe reverb. So you've all seen these before. Obviously this is a reissue, it's not the original item. And we've got the normal channel, the vibrato channel, volume, treble, bass on the normal channel, and then vibrato channel, volume, treble, bass, reverb, speed and intensity. So let's plug it in and see what's wrong with it. Just listen to that. And the volumes are turned down. And it's on the current limiter with 160 watts of current limiting. That's with the current limiter off. That's terrible. Ah, it's the reverb. So has the reverb got a fault then? I was going to say that. So that must be faulty. Must be. Oh, and the reverb tank's loose. Oh, the plot thickens. Is the reverb tank disconnected? Because I don't see any cables going up to it. Let's turn it round and have a proper look. Right, we are looking in the back and we can see a Jensen special design speaker. We've got the foot switch for it here. Let's turn that reverb up again. Where is it? There. Let's have a bit of a brevet under here. Well, it seems the tank seems to be functioning. Let's see if the reverb is actually reverberating with a signal through it. By gum, that's noisy. It's kind of working, but not working. Very microphonic tube somewhere. I think we better get this out the case and have a good look at it. Right, it's out on the bench. It looks like it's got all its original tubes, well, the output tubes and the rectifier look original. Let's get the dog house opened with the Infinity Temu drill, which still hasn't been charged up. And it's the original IC caps in there. Yeah, they're looking good order, but we usually get rid of those. So we've got 47 at 500, and we've got 322s at 500, 220 microfarad at 100 volts. And I'm wondering if I've got one of those. We shall have to check. We could test them as well, just for fun. And before we do that though, we'll discharge them, or make sure they're discharged, so we don't blow the tester up. So just use this rather large resistor here to discharge the capacitors. And now we shall test them. See, let's just put this on manual focus as well. There we go, and just a tap there. .30 ESR 5.3, so that's a little high. Let's try the next one. 22 at 5.4. In circuit, oh, the wires come off, I think. Before it finished testing, let's try again. Oh no, that one's all over, look. That one's all over. So these are not healthy capacitors. It's also showing that as in-circuit leaky. Oh, there we go then. Let's try the 220 at 100. And that's the only one that tests good. That one actually tests okay. But the others are all over. So those will need to be changed before we do anything else to this amp. Let's spin it over and just check that Billy Bodger hasn't been in it. Didn't think I'd got one of those in stock, but that is 220 microfarad at 100 volts, and it's a Victor Vishay, so very good quality. Let's test him, shall we? Just for fun. Press the button. 250 microfarad. Oh, sorry. Bing, there we go. 215.9 microfarad at 0.22 ohms. I think he will do nicely. Although the one that's in it is good. It's been in a good while, and the others are no good. So it seems little point leaving that one in there when we can put him in there and make it top draw. Right, let's test some of these capacitors then. See what we've got here. So we start with these bypass caps. So I'll just bring that up a bit closer. So 24.39 at 1.27. So that'll be 20, probably either 22 or 25 microfarad. I think it's 25 in these. So he's pretty close. He's not too bad. Let's try this next one. Oh dear. So he's leaky. Let's try this one. He's not too bad. He's about the same, not bad. Try this one. Actually, I don't think I can get into that one. There's a blob of silicon on there. Well, that says 5 microfarad on that, 5.13 microfarad on that one. So I don't know, we'll have to have a look at that one then. Next one is here. About the same. About the same. And I can't test the radials because they're flat onto the board, the radial there. So I think we're probably as well changing these 25s. There's definitely, and I say there's one of those that's definitely no good. And most people would topside repair that. And if that's what you want to do, that I'm fine with that. But I'd like to take the board out and do them. It's just everyone has their own way of doing things. That's just the way I do them. But you can topside repair them. I'm not keen on topside repairing high voltage stuff, but I mean that's only a bypass cap. So yeah, you could topside repair that. It would be no big deal. There's what 1.5 volts going. Is that 1.5k? Yeah, so there'll be 1.5 volts ish going across that. So, but when you topside repairing, dropping resistors and things where there's high voltage, I'm not so keen on that. But that would be okay. But I'll still have the board out. There may be more things to do to this amp as well, because this amp belongs to Lee at the shop. It's been upstairs for months, so I've really got to get onto this and get it finished. But he wants some mods doing to this amp, and Psionic Audio did a video on these amps, which was quite extensive apparently. I've not watched it, but Lee's watched it. So he's going to send me a link to that, and I'm going to have a bit of a look and see what was done to this amp, well, not this amp, but this model of amp, and see if we can get some pointers, because you can always get some pointers from Psionic Audio. He's a very good tech. Right, I'm going to retire for a few minutes because it's time for lunch. Right, I've got the schematic here, and we've changed the capacitors on here on the board, which you can just see, all but one. Now this 220 microfarad capacitor at 100 volts is in series with this 47. And if we look on here, and I get a pointer, and we'll put the camera on manual focus. There we go. We can see that here in series with the 47. Now, I had a bit of a look at one of the Sonic Audio videos, and Mr. Coleman just leaves this cap out. What he does, there's a balancing resistor. Not sure what value that is. Let's have a look on there. It is 100k. It's R65, and he just puts a jumper across that, across R65. And I kind of got to thinking as well, you know, there's not a lot of voltage on this amp, because what that does is that's 500 volts, and the cap that came out was 500 volts, and then the 100 volts in series will make 600 volts. And you're thinking, well, if we look here, coming up here, we've got 300, after it's rectified by the 5AR4, we've got 396 volts. Also, the 5AR4, or GZ34, is slow start. So it will never reach more than 500 volts. So your first thought is, well, why have they put that cap in there? And, you know, I was thinking much the same. It's not really, can't see the point in that. And then I sat and had a really good think. And then I suddenly thought, what if somebody puts a solid state rectifier in this amp? So the first thing I then went to look for was there any voltages for the AC coming in? And there isn't, because obviously then I could do the maths on that and see whether that was over 500 volts. That's the only reason that I can think, sorry, I've dropped my pointer. That's the only reason I can think of putting that extra capacitor in, because this, you know, this will come up slowly. It's a slow start voltage, so it will rise slowly. So I'm wondering if that's being put in to prevent someone putting a solid state rectifier in this amp. And the plug-in ones, you've seen me make them up for some of the Masco amps, and sometimes I use them when I'm testing, but obviously I'd have the amp on the current limiter, so I can bring up the caps slowly. In fact, I'll put one in this one to bring the caps up slowly, but obviously we won't put full voltage through it. And then what we do is, once we've brought the caps up, we'll take it out and then we just put the rectifier tube back in. So it's always controlled. But if somebody put a solid state rectifier in this, and then they switch the amp on, you would have quite a high voltage before the tube started conducting, and then that voltage is reduced. And I can see, you know, I can see why on the video he left that out. He's not bothered to put that in, because there's no point. And there is also a small advantage gained in the fact that with that capacitor in series, you're only getting 34 microfarads on the first node. If you remove that, you get the full 47. So I can see fully why you would leave that cap out and just jumper the balancing resistor there. Just put a jumper in. And I'll be honest with you, I didn't spot that on the last one. Well, I saw that it was in series, but I didn't really pay that much attention. I was just wanting to get it recapped and finished for the customer. I never really sat down and analysed it. It was only when I watched that video and I thought, oh, that makes sense. But then you're kind of scratching your head thinking, well, what did they put that in there for? There must be a reason. So I'm going to have a test to see if that is the case. Right, we're going to power this amp up now with the new capacitors in. I've put a jumper across R65. I'm going to remove that 100k resistor. And I've got a solid state rectifier in this amp, so we could bring these tubes up slowly. Now we're not going to bring it up to full voltage on that, obviously, because it'll push the bias over on the tubes, just enough to get these caps. We're going to run them up slowly, and then when we get them to a reasonable voltage, we'll just drop onto the rectifier tube again. We know from the schematic what the rectifier tube is giving us, so as long as we don't exceed that voltage, there'll be no problem. So we've plugged in. We've got a low wattage bulb in to start us off, and you can see that's given us 59 volts, and that's climbing slowly. So we just don't want to shock these caps to life. There we go, 67, and we've got 118 volts going into the amp, but that looks right. So now we've got that up to 77. We'll put another 25 in with the 15, and that'll bring us up again. You can see the voltage is going up now. It's going up steady. Bulbs are dimming. Got 120 volts going into the amp. And you should see that voltage begin to drop now on there, and it is. You can see it dropping because the tubes are conducting. The wall voltage is dropping as well, 114, 13. And you can actually see that if we bring the camera down in shot just a little bit there. You can see that on the wall there. Pilot light is lit. And we've got sound already. The signal generator in there. Yes, we've got sound. There we go, got 85 watts of current limiting. You can see that coming up now. Drawing 180 milliamps. So we'll go up on the bulbs again. We'll go up to 160 now. There we go, 364 volts. Let's just move this down so we can see the amp. 365. Got some frying. So the maximum voltage with the rectifier tube in at the point that we're testing is 398 volts. So as long as we don't exceed that with the bulbs, we'll be fine. And we're pretty fine now anyway. We've run those caps up. And that's pretty good. There's a bit of frying somewhere. Might just want the tube sockets cleaning. So yes, all good. That's all looking good. So let's just put 200 watts of current limiting. Let's just see where that leaves us on the voltage. 383. Yeah, that's fine. So we're not going to switch it off, the current limiter, because we'll have too much plate volts then. We've got 211 volts going into this amp. So that's pretty good. Now let's turn the reverb up. Well, the reverb is up. So notice how quiet the reverb is now. And the reason for that is that if you remember when we tested those capacitors, one of them tested in circuit leaky, and that was the one that was powering the screen voltage, and the reverb transformer, the output transformer for the reverb, is also fed from that capacitor. It's smoothed from that same capacitor, and now you can see it's much quieter. There's a little bit of noise when you turn it up, but not like it was before. It was absolutely, and remember we've got no reverb tank connected, it was absolutely horrendous. So that's one problem cured just by changing the capacitors. So if you buy one of these and you turn up the reverb volume and it's very, very noisy, you know, really humming and buzzing, whatever, then you know that's, chances are that electrolytic that smooths the screens will be kaput, as it was on this one. Right, that's all looking good. Now, as I said, as we were looking on there, I've left that cap out of the doghouse, that 220 microfarad. So there's two reasons why I've put the solid state rectifier in there. One is so I've got more control when I power this amp up with the new caps in. And secondly, I want to test this amp now with the solid state rec in. So what I'm going to do, I'm going to power this amp off now. We know it runs, there's no problems. We're going to let it just cool down for a bit, and then what I'm going to do is I'm just going to start this amp on the solid state rectifier. I'm going to switch on and I'm going to see where that plate volts hits, and if it's under 500 volts then it will be fine to leave that capacitor out. However, when we fire it up, if it just tips over 500 volts, then that cap will have to go back in. Right, so we're watching the meter there. So let's just switch on and see what we get. $455 was the maximum there. Just drop the current limiter back on, so restricts the voltage as it comes up. Yeah, 455. So it's perfectly all right to leave that cap out. No problems there. Just had to do that test to be sure, because as I said, couldn't understand why they'd put that cap in there, and so yeah, I'm sure Lyle checked that before he you know, before he took that out or decided not to put that back in. But I just wanted to check that, because there's absolutely no reason why they put that cap in now. The only reason it could have been is if anyone put a solid state rectifier in this amp. That's the only reason, because it just won't on a, and I'll show you what I mean. We'll switch off. We'll just let the voltage go out the caps before we start messing. So you saw when I switched that on, the rectifier, the solid state rectifier, immediately fired 455 volts onto those capacitors. But they'll take that because they're rated at 500 volts. If they'd have gone over 500 volts, then we could understand why they'd put the 220 microfarad in series. So a bit of a strange one, that. Don't really know why that's in there. And it's actually better without it, because now we've got more microfarads on the first node. Right, so now we've got the rectifier tube back in there. So we switch on, and you can see now switched on, we're seeing no voltage. That's just what's left in the caps. And then as the tube begins to conduct, you'll start to see that rise, and now you can see it going up there. And there we go. And that should go up and then back down again. Actually not doing. Thought that would just come down a little bit, but it's not. So we've got 424 on there. And I know why we've got 424 on there, because this amp's set at 230 volts and it should be set at 240. That's giving us 425 volts at that point where the at the cathode of the cathode, sorry, shall I say that again. So at the cathode of the tube rectifier, we should have 396 volts or 398. I can't quite read what that says on the schematic. It might be an 8, but we're splitting hairs over 2 volts, and we've got 426. And the reason is because this amp is set at 230 volts instead of 240 volts, the usual deal due to the EU rules. That's why we've got that extra voltage there. So you can see the way that tube rectifier came up there, it just came straight up to normal volts. It didn't, you know, you didn't get that, like we got that 455 straight onto the you know, straight onto the plates of the tubes even before they'd warmed up. With this you don't get that, so we don't need that capacitor. This amp's not getting even close to 500 volts. It's got a good 45 volt window even with the solid state rectifier in. So that's that solved, so we can leave that out. And actually I'm rather pleased I can leave that out, because here, if we go down and across slightly, it's quite a long chassis this, but here you can see a little board on the side, and that board, I'll get something to point with because this amp is switched on. This board here, and this board has got two 220 microfarad capacitors on there, and I'd only got two 220 microfarad caps, and one was earmarked for going in the doghouse. But of course now I don't need to put that in the doghouse, so I've now got all the caps for this amp, because obviously it's very close to Christmas and the chances are I won't get one of those before Christmas, and I want to try and get this amp finished if I can. So that is a little result for me. So we're looking at this diagram here, and we've looked at these before. So 230 and 240 volts, and if you look at these wires here, you can see how they correspond to this mini graph, if you like, you want to call it that, or tables. So CP6, they're identical, that's black and yellow. CP7 and CP7 is white. CP2 on 230 volts is white black, and CP8 is black. But on the 240, CP8 is white black and CP2 is black. So we need to check on this amp and see what we've got on there, and then we're going to swap these round. And I'm just checking the meter, those caps have discharged because the meter's still connected before I start getting in here. Now just having a look, so CP2 should have white black on it. Let's see if we can find. There's a white black wire, and I'm trying to look over the camera, so if I'm moving the camera about, I apologise. And do you know, I think my eyes are getting worse. These glasses are 3.5s. I think I'm going to have to get some even bigger ones. I won't start with the Elton John jokes. Let's just take that off of there. Oh, that's made the thumbs whine a little. and that is indeed CP2. So that we have got this set at 230 volts. So let's remove CP2, and now we want CP8. CP8. Just check with this eyeglass, because the CP8. Right, we found it. Multiple choice black wires there. So we need to swap those over, plain and simple. So that goes in on there, and then white black goes on CP8 that we took an age to find, probably because I'm a bit of a plank. As I say, it's not that long since I worked on the 68 reissue, but I mean, I don't work on many of these. You know, some of you guys in the States, you're probably working on them, you know, one of these a month or more, but I don't see very many of them. In the UK, there's a few of them, but of course not all of them are in for repair. Some are running happily and merrily. So that's changed that over. So now we're looking at the meter again. I'm just going to pop the bulbs on though while I do this. I just whenever I've changed anything on an amp, because I may knock something or whatever, so I'm going to put the bulbs on because that'll give me protection. The amp is on, bulbs aren't lit at all. So now we've just got to watch that voltage. I'll flick off the current limiter. I think we've got to probably just pop it back on till it goes up, gets up to voltage. There we go. Now you can see we've got 346 on the current limiter. Let's take the current limiter off. And there we go. Now I've got 405 volts on there. And we should have 396, so a little bit over, but not a mass. And it'll probably come down a little bit more as the tubes get swaging. Bias might be a little off as well, you know, just a little bit off. Tubes might be biased a little cooler than they are on the schematic, but that's a damn sight closer. 7 volts over what's on the schematic. So there we go. So that's sorted that out. So now we've got to look at taking this board out. That's the next job. So let's just see what caps we need to change on here then. So we've got 1, 2, 3, and I will probably need the eyeglass to look at some of these because they're quite small. So those are all 22s. They'll be the bypass caps. They've got the 1.5k resistor at the side of them. That one's also a bypass cap. For that, probably, yes, 22. That's a 22. This one here, I bet you can see the top of my hat now, can't you? Can't see what that one is because they've very gracefully of them, they've put it with the values face down. And then we've got another 22 here, so that could be a 22. When we measured that one, it measured 5 nanofarad if I remember. I think it did. Let's get the tester out again and swage it. So that's the one that they've got the junction round the pin on the end, and we could only just get in when we tested earlier. Analysing. Yes, 5.16 microfarad. So either that's a 4.7 that's gone high. Go on to manual focus again. There it is, C19, 4.7. So yeah, I was right, it's 4.7. a slight tea stain on there. I did say tea. Right, we've got this board up, and we've also got the preamp board out there, and we'll be looking at this in a bit more detail, what we're going to do with this. Not a lot of changes on here. In fact, we can look now. So we just, it's going to manual focus. There we go. So on the, we're cutting out the bright cap, which I think is C10, but we'll check again on the schematic before we do any snipping. And then the normal channel, which will be this channel here, which I presume will be these capacitors here. We've got 100 nanofarad and 47 nanofarad, which I think is C9. We're going to change C9 to the 22 nanofarad, which is the mid cap, which is what Lee wants, and that will be the same as a super reverb tone stack. So that's that. And then this channel we're leaving the same. I'm just going to up the plate resistors because they're those 1/4 watt things in there, so we'll probably just upgrade those a bit, maybe a 1/2 watt if I've got them. I'd like to get a watt in there, but they're too big, I think. But we'll try and get some 1/2 watts in there, just make it a bit more reliable, with those being 1/8 watts. Very small resistors. Right. So we've got to a point where we're ready to fire this one up. I've just got the output tubes to put back in, because obviously I've been soldering on the sockets. So let's just have a look at what we have done then to this amp, because we've done a lot, a hell of a lot. So in the last clip, we'd still got the board out and everything, and I was explaining some of the things that we were doing. So those are all done now, and the board's down. I'd removed the screen resistors from the board, and I've put the screen resistors on the tubes. I've upped those to 1K. 1.5 grid stoppers, I also took those off the board, and I have put these here on the sides. These resistors have got quite thick leads. The reason is, I mean, some people put them from pin 1 to pin 5, and you can do that. They go right across the tube, and because this it hangs upside down in the cabinet, the heat rises. So it's just to keep the heat off the grid stopping resistors there. So I've put them on the side. You don't have to, it's just the way I do it. But there's nothing wrong with putting them across there. It's just, for me, it just keeps the heat off them. This board I've had out, and those two 220 microfarad capacitors test just fine. Perfect. So I've left them in. Doesn't seem any point taking them out. And should they ever fail, it's not going to, you know, nothing serious is going to happen in this amp, and they're quite easy to remove. Just 2 screws, boards out. You'd have those changed in 10 minutes. So we've left those, they're fine. So the board's all back in now. Now we've got this screened cable here, and this is one of Lyle's mods, and it's one of the mods that Lee wanted doing to this amp. And this is from the wiper of the volume on the vibrato channel down to the grid there. Now, the other thing about this amp is it's got some grid stopping resistors on that aren't on the schematic. So I don't know whether they were added at the factory or whether someone's added those in the past. But anyway, they're on there. And so I've put the 10K back on the end of this wire here. And basically this, and I haven't, again, I've not looked under the board. I mean, Lyle's done this mod, so as far as I'm concerned, if he says there's a problem under this board, there's a problem. I'm not even going to question the guy, because he's far more advanced than I am. But apparently this grid wire here, this goes to the grid of pin 7, which is V2B, runs alongside some high voltage, and it under the board the traces are close together, and it causes humming So this is what this mod is for. So I've just done the same thing, and if that's good enough for Lyle, then it's good enough for me, so that's fine. As I told you, we changed all the caps on this board, all of them. They've all been changed. I've gone right through it, and some of these caps were probably leaky because the values were high on it. And someone, and I've not had time to reply to a lot of the comments, but I do keep reading odd ones when they pop up because I have to approve them. One guy left a comment yesterday, I think, about the peak meter that we've been using, and I'm obviously using that for the first time. You getting used to meters and things when you first use them, and he said that if you find high values on a lot of these components when you're testing them, they're probably leaky, and he is actually right about that, because the more I've been using that meter and experimenting with it, I've actually come to that conclusion myself as well. So yeah, we get some good comments and good info, so thanks for that. And yeah, that is right, after doing a bit more experimenting. So useful tool, that peak, where is it, that peak tester, where I've put it now. So this tool here, very useful. Although some of these capacitors did say in circuit leakage, so you know, we took those out, tested them, and they weren't clever at all, those capacitors. So we just changed the lot, done the lot, and that's it. Now the other mod that we've done on this board, on this preamp board here, which you can't see because it's just tucked, this is just shielding it from the camera. I've not put the knobs on yet because if there's a problem I might have to take that board out. So let's just have a look at the tone stacks. We changed just one component in the tone stacks. There we go. So if we have a look, if we go in, don't know how that's going to be a bit overexposed, and we'll just tap that just to make sure it's in focus. So this here on the normal channel, this 47 nanofarad 0.047, my eyes, we've changed that to a 22 nanofarad. So from 47 to 22, that is for the Fender Super Reverb mod for this channel. So we've got that done. The slope resistors 100k, I've upped those to half a watt. They were quarter watt. I've just upped those, and again, that's another useful mod that Lyle does, and that makes sense. They've got some, you know, reasonable voltage on them, so it just makes them a bit more reliable. So we've done those, and we've clipped out, and again, Lee wanted that doing, we've clipped out the bright cap, which is on the volume there, the 47 picofarad. We've clipped that out as well, so that's gone. So yeah, so they're the mods on there. Caps are absolutely fine in this board here, and you can't quite see it, so that board I was talking about with the caps is here. So those two caps are perfect, so we've left those in. We've got the screen resistors on, we've got the grid stoppers on there, so if we just come around again, and we've got all of these caps done, and the amp's now ready to fire up. So I've just got to pop the I've already popped the preamp tube back in after I soldered that up, because again, we don't want to be soldering on the pins of the tube. So we've just got to get the output tubes in there now, and we're going to get this fired up. Right, we are ready to fire up. So current limiter is on. I've just got a 100-watt bulb in it. We're on. Bulb's lit up and gone dim, so that's a good sign. Good start. Let's get the current signal generator going. In there, we'll go into the normal channel first. Just starting to get some plate volts now, you can see. Drawing 180 milliamps, so that's good. Wow, already we're there. Try the other channel. That's good. Wow, that's a brilliant mod. That is, this cable here, this reverb now is just silent, and that whole channel is just wow. He's one clever dude. He is one clever man indeed. That's really good. Wow, that's quiet now. My word. Let's just set the bulb off. Yeah. That's just the phone. You can hear. That's good. That's very good. Right, I'm going to get the knobs back on it now. And then we've got some of these tie wraps to just put up and tidy these wires a little bit. And then we'll check the bias. And we'll scope it. Check these screen resistors are okay. There's no problems there. And I think that should do it. We'll be... we've got the reverb tank is loose in the bottom of the cabinet, mind you. So I've got some... I need to check that. But other than that, we're looking good, actually. We're looking pretty darn good. Right, we've got all the readings we need for the bias. So we've got 202 on brown, 205 on blue. That's measuring the impedance across each side of the output transformer. The volts drop is 3.45 and 3.42. That's measuring across centre tap again and the plate, but this time with it switched on, so we get the voltage drop. And then we've got the plate volts from the plate to ground is 407. Now, centre tap on this amp is CP15 if you're doing this. CP15. And that, if we just go down, I'm just going to have to go back with the camera so you can see. And that is here in this block here of spade terminals. So CP15 is what you need to test that's the centre tap, and then obviously the plate. And you're better off doing this with the volumes turned down as well. So if we go up, we can see our meter's ticking away there. So we've got the last of the readings, so we can switch off now. Now I also checked the negative volts on pin 5 on the grid of the output too, so it's negative 37. That's what it calls for on the schematic, but I never set the bias with negative volts, but it gives us an idea. So let's start with brown. So 3.45 divided by 202. That gives us 17 milliamps. Remember, we're looking for, what's 17? So 14 watts, these tubes, aren't they? Because they're 6V6S as these tubes. So we are looking for 70% of 14, which is 9.8. So that's what we're looking for, 9.8 watts on the bias. So 3.45 divided by 202 equals 17 milliamps. Times that by 407 is 6.95. So they're low. They're quite low. 6.95. That's pretty low. Let's go to the other side. 3.42 divided by 205 is 16.6 milliamps. Times by 407 is 6.7 watts. So these tubes are pretty well matched. 6.7 watts. So pretty well matched, these tubes. There we go. That's not bad. Well, actually we reduce it, not up it. Let's go to negative 35. What you see on there? That'll do. Let's see what that gives us now. So let's do the maths on that. Now I've only done one side. So 4.3 divided by 202. Yep, times 400. And that's 8.5. We've got there now, 8.5. So let's go into standby again. Just let the voltage drain off. Negative 34. Let's try that. Yeah, it's 23.7 milliamps now. So let's see what plate volts we have. Go into there. Times 397, and that's 9.4. That is 9.4 watts. So we know the other side is going to be 9.1, don't we? More or less. It's in a window. So that's good enough for me. That's near enough, because we've got 230 volts coming in on the 234 volts coming in on the wall, and later on tonight that will have gone up to 240 or 242, and so that 9.4 will easily become 9.8, and that will be spot on. So that's where we're going to leave it, 23 milliamps. Let's try the vibrato channel. And of course we've got the reverb. amp's much quieter than it was before. Obviously we recapped it, and then some of the Psionic Audio mods that's got into this amp's made it even quieter. And even though the reverb's full up now, you can hear the background noise, but it's not viciously humming or anything. And that is all the reverb in. Oops. So yeah, it is just about half the reverb. Let's try a single coil. Take some of the treble out. The single coil. This guitar is very bright though. Pretty nice. Yeah, that's sounding gorgeous now. Really nice sounding amp. A lot of work to get this right, but it's been worth it. and I think Lee's going to put a better reverb tank in there, and he's also going to change the speaker for it will be another Jensen, but I can't remember which type now. He did tell me, but I've forgotten. So there we go. So that'll do it for this one, and yeah, if I don't see you before, you all have a good Christmas. May get another video in before Christmas, but if I don't, then you all have a great Christmas and a good New Year, and I'll see you all in the next one. So take care now. Bye.